Hey, Algebra 1 students. This is lesson 10-5B. This is factor by grouping. And what we're going to take a look at today is what we've done in the past, like what was our experience before with factoring, and then what this new skill is and why you need it. So let's look at a problem that we've done before where I'm going to say that we want to factor using the GCF. And remember that the GCF is the greatest common factor. And the polynomial I want to look at is negative 16x to the third plus 40x squared minus 8x. And we need to look at all three of those terms. We have a trinomial right here and decide what's the GCF. What do all of those terms have in common? And what's the largest thing that we can divide out of all three of those terms? So we can make a list of all the factors of 16 and 40 and 8. But probably the best way to do this, the best shortcut, is that you take the smallest number, like 8, and you say, okay, what are the factors of 8? Well, that would be 1 and 8, 2 and 4, and then 3 doesn't work, and that's the only thing that's in between 2 and 4. So I know that's the whole list, 1, 2, 4, and 8. So I'll start as high as I can, because if something is going to be a common factor, that means that it's got to be one of these four numbers. There's only 4 possible terms of 8. So I'll look at the 16 and the 40 and see if they can be divided by any of these factors. Start at the high end. I'll start with 8. Is negative 16 divisible by 8? Yes, it is. It comes out to be negative 2. Yay. Okay. Is 40 divisible by 8? Yes, it is. That's 5. And so both of those other two coefficients here, the 16 and the 40, are divisible by 8. So that tells us that the GCF is going to be an 8. Now, before you say, well, I'm all done, we should look at the x's. So our variables here, I've got x to the third, x squared, and x. So you have to ask yourself, okay, what do all three of these terms have in common? Well, there's 3 x's here, 2 x's here, and only 1 x there. That means that what do they have in common? There's at least a single x in each of those terms. So when I look at this GCF, I'm going to say that it is 8 and a single x. Now, also, there's one more thing in play here, and that's that our leading coefficient is negative 16. And you might remember that when we have a negative leading coefficient, that's the situation when you should use a negative GCF. So the GCF I'm going to use here is negative 8x. Now, I'm going to write that GCF underneath the entire polynomial, and then we're going to divide 3 times. Okay, so the first one I've got here is negative 16 x to the third divided by negative 8x. Negative 16 divided by negative 8 is positive 2. And then x to the third divided by x, well, that's going to cancel off one pair of x's and leave x squared behind. Now, positive 40x squared divided by negative 8x. So that's 40 divided by negative 8, which is negative 5. And then x squared divided by x, that's going to cancel off one pair of x's, so there's only a single x left behind. And then finally, I've got this last division problem over here, negative 8x divided by negative 8x, which anything divided by itself comes out to be 1. And that is what's left behind after you divide out the GCF. So to finish this problem, then we need to put our GCF out front. I'll write negative 8x in front of the parentheses, and then this trinomial here is the rest of the answer. Okay, so that is not factor by grouping. That's just factor with GCF. So why do we need a new method? Looks like factoring with a GCF works just fine. But let's check out a different kind of problem. The new problem I want to do is I want to factor 2uv plus 6u plus 5v plus 15. Okay, and the first thing I want to ask myself is, what is different between this problem, the new one, and the one that we just did a minute ago, factoring with the GCF? Well, I can see 2 things that stand out to me right away. First thing I'd notice is that down here in the variables, I have both a u and a v, And in the original problem up here, there was only x's. So this time I have two different variables floating around. The other thing I see is that this time I have 1, 2, 3, 4 terms in this polynomial, not a trinomial anymore. It doesn't have a special name since there's 4 terms. It's not a quadnomial or anything like that. But those are the two things that stand right out to me in the beginning. What else is different? Well, let's look at a GCF. Okay, so I see in the numbers, I have a 2, a 6, a 5, and a 15. Those numbers don't have anything in common. And I can tell right away because the GCF, if I look at the smallest number up there, it's 2. Okay, well, sorry, if I want to look at just factors of 2. So I'll say, what are the factors of 2? Just 1 and 2. Okay, well, that means that a GCF has got to be one of these two numbers. And right away, I can tell that 5 is not divisible by 2, and neither is 15. So that means 2 is not going to be the GCF, and the GCF is only going to be 1. But that doesn't really do anything for us. If we divide 1 out of every term, that doesn't change anything. And so there is no GCF as far as the numbers go. How about the variables? There's a u and a v, there's a u, there's a v, and there's a nothing. No variables on this last term, it's a constant. And so there's no variable that can be part of the GCF either. So overall, if I look for a GCF, the only GCF is 1, and that doesn't really do much for us as far as factoring goes. So we need another option, and that's where this thing called factor by grouping comes in. What we're going to do is pretend like this problem, which has 1, 2, 3, 4 terms in it, is really two separate problems. You're going to look for the middle. So here's the first term and the last term. There are the two middle terms. And if I divide right down the center, that divides this polynomial into two equal pieces. Now I'm going to pretend as if these are two totally separate problems. I'll look at this first set of terms, 2uv plus 6u, and I'll ask myself, what is the GCF of 2uv plus 6u? Okay, well, let's go number part. What's the GCF of 2 and 6? The biggest thing that can divide out of both 2 and 6? Well, that's 2. How about the variables? I see that there's a u here and a u here. There's a v here, but no v over there. Okay, so v cannot be part of the GCF, but u can, and there's a u in both terms. So there's a single u that can be divided out of both terms. So we'll write that as 2u is the GCF of the first two terms. Now, you can either go on and do the second two terms right now, or you can finish this first side. Either way, it doesn't matter. But I think what I'll do is I'll finish the work that's over here first. I'm going to divide 2uv divided by 2u, just like we did up above. So this division first. 2 divided by 2 gives me 1. U divided by u also gives me 1. And v, nobody's dividing out of v, and so v is just still there. So that's like saying it's a 1v. What happens when you divide positive 6u divided by 2u? 6 divided by 2 is 3, positive 3. And u divided by u, those two u's cancel each other out. They're gone. And so in the parentheses, what's left behind after you divide out the GCF is 1v plus 3. And then this GCF goes right out front, 2u. Okay, now I need to pause and come over here and look at the other side. I've got 5v plus 15. Okay, start back over again and ask yourself, what's the GCF of just 5v plus 15? What's the biggest number that can divide out of 5 and 15? That's 5. And 15 doesn't have any v's on it, so that tells me there can't be a v in the GCF. So we'll just divide both terms by 5. 5v divided by 5, well, 5 divided by 5 is 1, and that v is not going anywhere, so it stays. And then 15 divided by 5 is 3, positive 3. Okay, that's what's left behind in parentheses after we divide out the GCF, and the GCF goes out front. Okay, now you should notice something interesting about what happened here. The part that was left behind, the parts that are in the parentheses right now, match each other. And when that happens, that means factoring by grouping has been successful because we need to do one more step and look at this 1v plus 3 as if it's like a GCF as well. That right now, this positive 5 that we divided out and this 2u both have a 1v plus 3 being multiplied by them. I'm going to grab both of these two, and they're going to become 1. And they're going to come out front in one copy of that repeated parenthesis. So I'll write this single copy as 1v plus 3. And of course, if you want to write it just as v, that's totally fine as well. So there's a single copy of that repeated parenthesis. Now the other parenthesis, our other factor, is going to be the two GCFs that we divided out earlier. I've got 2u and I've got plus 5. So this number or this term came from right here, and this term came from right there. So one copy of the repeated parenthesis and the two GCFs make the other parenthesis. Now it seems like magic, right? Like, how does this really work? Well, the best way to check this is to actually do the check. Okay, well, the opposite of factoring is multiplying. So let's multiply those together. Okay, if I multiply together 1v plus 3 times 2u plus 5, there are a few ways you might do this. Some of you like to do the FOIL method, which means first you multiply the two first terms, 1v times 2u, and that would be 1 times 2 is 2. And then v times u is just uv or vu. It doesn't matter what order you write them in. We'll put them in alphabetical order. Outer means 1v times 5. So that's plus 1 times 5 is 5 with a v on it. Inner is 3 times 2u. 3 times 2 is 6. And then there's a u on that term. And then finally, last, 3 times 5. 3 times 5 is 15. And what do you know? Those 1, 2, 3, 4 terms right there exactly match the 4 terms that we started out with. The only slight difference is that notice here I have 5v plus 6u, and up at the beginning it said 6u plus 5v. But we know that when you have polynomials, it doesn't actually matter what order they're written in. Usually we put them in order, so like the earliest letters in the alphabet come first. So we could move these two around so that it said 2uv plus 6u plus 5v plus 15, and now it exactly matches the problem that we were given to begin with. And that's how you know that your factoring has been done successfully. So here is the answer. Okay, this right here is the factored answer. And down here, this was our check to make sure it actually was true.